guys, welcome back to my Pro vs YouTube channel where curiosity meets the code. Today our topic of discussion will be blockchain algorithm. This is the series where I describe all kinds of algorithms in different fields. So before we went through some other algorithms, so let's get started with blockchain algorithms. So firstly, we will be introducing you to blockchain, basics of blockchain, why algorithms matter in blockchain, consensus algorithms overview, smart contracts, security measures, use cases, challenges, limitations, and future trends. So let's get started. Firstly, what is blockchain? Blockchain is a decentralized and distributed ledger technology that securely records and verifies transactions across a network of computers. It operates on a peer-to-peer network, eliminating the need for intermediaries and offering a transparent and tamper-resistant systems. Then we have each block in the chain contains a cryptographic hash of the previous block, creating a linked and immutable sequences. What is the importance of algorithms in blockchain? Algorithms play a crucial role in maintaining the integrity, security, and consensus with the blockchain network. Then we have consensus algorithms such as proof of work, which is POW, and proof of stake, which is POS, enabling participants to agree on a validity of transaction without a central authority. Then we have smart contracts powered by algorithms automate and enforce the terms of agreements, enhancing the functionality of blockchaining beyond simple transactions. Then we have blockchains. Resilience and trust are rooted in cryptographic algorithms, ensuring secure communication, data privacy, and protection against malicious activities. Some of the basics of blockchain include decentralized distributed ledger, and decentralized systems control and decision making are distributed across multiple nodes or particular rather than being concentrated in a single entity. Then we have decentralization minimizes the risk of single point of failure and prompts a more resilient and censorship resistance network. Then we have transparency. Blockchain ensures transparency by providing a public ledger accessible to all the participants in the network. Then every transaction is recorded in a transparent and verifiable manner, fostering trust among participants. Then we have immutability. Immutability guarantees that once a block is added to a blockchain, it cannot be altered or deleted, achieved through cryptographic hash function and consensus mechanism. Immutability enhances the security and reliability of the ledger. So why algorithms matter in blockchain? Firstly, we have to ensure security and consensus. So blockchain relies on cryptographic algorithms to secure transaction and data. The consensus algorithms such as proof of work, which is POW, and proof of stake, which is POS, ensures agreement among the network participants about the state of the ledger. Then we have security is maintained through the complexity of cryptographic puzzles, which is POW, or the economic state of participants, which is POS, preventing malicious activity. Secondly, we have this algorithm makes it computationally infeasible for a single participant or a group of participants to manipulate the system. By achieving consensus, blockchain established a single version of truth, preventing double spending and ensuring the integrity of the ledger. Next, we have facilitating trust in a trustless environment. Firstly, we have blockchain operates in a trustless environment, meaning participants don't need trust each other or a central authority. Then we have trust is established through the transparent and verifiable nature of blockchain transaction, where the rules of the systems are enforced by algorithm rather than the trust in intermediate. The use of consensus algorithm ensures that all participants agree on the validity of transaction without relying on central authority. Then we have trust is further enhanced by immutability of the blockchain, as once information is recorded, it cannot be altered, providing a reliable and tamper-resistant history of transactions. So what is consensus algorithm? Firstly, consensus algorithms are the protocols that ensures agreement among the nodes or participants in the blockchain network regarding the state of the distributed ledger. They play a pivotal role in maintaining the integrity and security of the blockchain. The purpose is to establish a single version of truth in decentralized systems and to prevent double spending and maintaining the order of transaction. The importance being containers algorithms enable trust in a trustless environment by ensuring that all participants agree on a validity of transactions. So some of the POW of consensus algorithm. Firstly, what is POW? As before, is a consensus algorithm where participants know as miners solve complex mathematical puzzles to add a new block to the blockchain. The first miner to solve the puzzle broadcasts the solution for verification. How it works? Miners complete to solve the cryptographic puzzle by using computational power. The first to solve the puzzle adds a new block and solution is verified by other nodes in the network. What are the advantages and challenges? Advantages include security and decentralization. Challenges include high energy consumption and scalability issues. What about POS? Again, POS is a consensus algorithm where the creator of a new block is chosen in a deterministic manner depending on their wealth or stake in cryptocurrency. How it works is participants with higher stake in cryptocurrency have a higher chance of being chosen to validate transaction and create new blocks. This reduces the need of extensive computational power, making POS more energy efficient than POW. Then we have advantages and challenges. Advantages include energy efficient and scalability. Challenges include potential centralized based on wealth distribution. Next, we have delegated proof of stake, which is DPOW. This is also a consensus algorithm where a small number of nodes known as delegates are elected by the community to validate transaction and produce blocks. Delegates take turns in confirming transaction and creating blocks. How it works is delegates are voted into their position by coin holders, enables faster transaction confirmation compared to traditional POW and POS. What are the advantages and challenges? Advantages include scalability and faster transaction times. Then we have challenges include potential centralization if a small number of delegates gain too much power. What about practical Byzantine fault tolerance, which is PBFT? PBFT again, it's a continuous algorithm designed to tolerate Byzantine faults where nodes in the network may act malicious or if it fails. How it works is it requires two-thirds majority of the consensus and participant particular block. The ideal for permission blockchain networks where participants are known. The advantages and challenges being advantages include quick consequences consensus in a trusted environment. The challenges include the assumption that only a minority of nodes are malicious. Then we have hash graph. So the hash graph is a distributed ledger technology that uses a gossip protocol combined with a virtual voting algorithm for achieving consensus. How it works is nodes share information which is called as gossip with each other about transaction. Virtual voting is employed to determine the order of transaction. The advantages here is advantage include high throughput and fairness. Then we have challenges include the complexity of the algorithm and potential centralized based on access to information. Next, what are some of the smart contracts? Smart contracts are self-executive contracts with the terms of the agreement directly written into the code. They automatically enforce and execute contractual clauses when predefined conditions are met. The purpose is to eliminate the need of intermediaries in contractual agreements, facilitate trust by executing action automatically when conditions are met. Then we have enhanced transparency and reduce the risk of fraud. Then we have Ethereum smart contracts. So Ethereum's role include it is a blockchain platform that popularized the use of smart contracts. Smart contracts on Ethereum are written in Turing complete language, allowing for a wide range of application. Then features include decentralized execution and enforcement of contracts, integration and decentralized application, which is DApps, and the broader Ethereum ecosystem. The example include ICOS, which is initial coin offerings, decentralized finance, which is DEFI application, and more. Next, we have smart contracts on other platforms. Example, Binance Smart Chain. Firstly, we have ecosystem expansion. The other blockchain platforms like BSC have introduced their own implementation of smart contracts. Then the comparison with Ethereum. BSC and other platforms offer alternatives to Ethereum, often with differences in speed, cost, consensus, algorithm. What are some of the use cases? Here, BSC supports various decentralized applications and projects contributing to a broader blockchain ecosystem. What should we consider? Factors such as transaction speed, cost, security, influence of choice of blockchain deploying the smart contracts. Next, some of the security measures with the cryptographic hash function. So, cryptographic hash functions are algorithms that take input data and proceed a fixed size string of characteristics, which is unique hash value. One way function, it is computationally infeasible to reverse the process and derive the original input from the hash. Then we have the security role. It is used to secure data integrity with blockchain. Each block in the blockchain contains a hash of previous block, creating a secure tamper resistant chain. Example SHA 256, which is secure hash algorithm 256-bit, is commonly used in blockchain. Next, we have Merkle trees. The definition being a Merkle tree is a binary tree structure that enhances data integrity by efficient summarizing large sets of data. Each leaf node represents a data block, and each non-leaf node is a hash of its children's. Then we have some of the security role. It enables quick verification of the integrity of a large data sets, and any change in data would lead to the change in the root hash, signaling potential tampering. The application is used in blockchain to efficiently verify and integrate of blocks and transactions. Some of the public and private keys. So, what are public keys? A cryptographic key that can be freely distributed and used for encryption and verifying digital signature, acts as an address to achieve currencies or other crypted data. The private key includes a secret key that must be kept confidential and is used for decrypting data and signing transactions. The controls access to the associated public key assets. Then we have the security measures. The security of the blockchain relies on the cryptographic strength of these key pairs. Then we are losing the private key may result in the loss of control over associated assets. Example being, in the context of a Bitcoin, public addresses are generated from public keys and private keys are used to sign transaction of the spending funds. Some of the use cases include financial transactions, secure transaction. Blockchain ensures secure and transparent financial transaction by using cryptographic techniques and decentralizes and reduces fraud risks and increases the efficiency of cross-border transaction. The smart contracts automate and enforces financial agreements, eliminating the need for intermediaries, enables programmable money, lending, and decentralized financial application, which is the FIs. Use cases include cross-border payments, remittance, peer-to-peer transaction, and decentralized finance platforms. Next, we have supply chain management, transparency and traceability. Blockchain provides an immutable and transparent ledger for tracking the entire supply chain, enhances traceability, reducing the risk of counterfeit products and ensuring product authenticity. Then we have smart contracts of automation. Smart contracts automate and enforce contractual agreements, reducing delays and disputes, improves efficiency in logistics and supply chain financing. The use cases include food safety tracking, product improvences, and anti-counterfeiting and optimizing inventory management. Next, we have healthcare and identity management. The secure health data exchange blockchain ensures the secure and interoperable exchange of health data among the healthcare providers. This enhances patient privacy and data integrity. Then we include identity management. Blockchain-based identity solution provide a secure and verifiable way to manage digital identities. This reduces identity, the theft, and ensures trust in online interactions. The use case being electronic health record, which is EHRS, clinical trials, data sharing, patient consent management, and self-sovereignty identity solutions. Next, some of the challenges and limitations in blockchain. Firstly, we have scalability issues with this, which is dealt with a lot. So, scalability refers to the blockchain's ability to handle an increasing number of transactions or users without compromising performance. The challenges include blockchain networks, especially those with high transaction volumes, may face scalability issues leading to slower transaction processing time as the number of participants and transaction grows. The compatibility of some blockchains to handle the load becomes a bottleneck. The solution being layer 2 solution. Sharing the and off-chain scaling solutions are being explored to address scalability challenges. Then we have ongoing research and development in blockchain space aims to improve scalability. Second thing is energy consumption, which is only to POW. POW and energy consumption. Proof of work consensus algorithms like the one used in Bitcoin require significant computational power, leading to high energy consumption. Then we have environmental impact. The energy intensive nature of POW has raised concerns about its environmental impact, contributing to the carbon footprints of blockchain networks. Then we have exploring alternatives. Some blockchain projects are exploring or transition to alternative consequences mechanism like proof of stake, which is POS, to migrate the environmental impact. Then we have the balancing act. The challenge is to strike a balance between maintaining security and reducing the energy footprint, pushing the industry towards more sustainable blockchain solutions. So, what are some of the future trends? Firstly, we have quantum computing and blockchain. The challenge here is to quantum computing threats current cryptographical algorithms. So, some of the response include research of quantum resistance cryptographical algorithms. Then we have the impact, which is intersection shopping the further of secure decentralized systems. The decentralized autonomous organization, which is DAOS definition include entities governed by smart contracts for decentralized decision making. Then we have applications, community governments, investment funds, and decentralized app decision making. The challenges or opportunity include addressing legal issues for democratic and transparent structures. Next, we have tokenization of assets. So, tokenization defined by representing real world assets as digital tokens and on a blockchain. The benefits include increased liquidified fractional ownership and transparency for traditional illiquid assets. The use case being real estate, tokenized securities, and art collection. The privacy and confidential in blockchain. The focus being emphasizes on privacy and confidential in blockchain. The technology includes zero knowledge proof for transaction verification without revealing details. Then we have some of the applications which include privacy focused cryptocurrencies, private transaction, and enterprises blockchain with enhanced confidentiality. So that's it for today. This was all about blockchain and its kind of algorithms, workflow, etc. If you're interested in any other topic, please do comment down below so that I'll be able to make the PPT and explain it to you guys. Thank you so much for watching. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.